Good morning, sir. Good morning, classmates. Today we're going to discuss about the roots and optimization. Looking to the overview, using the quadratic formula, where x is equal to negative b plus positive square root of b squared minus 4ac over 2a. To solve for f of x is equal to ax squared plus bx squared plus c is equal to 0. Now we are going to plot. Before we going to plot, we draw first the Cartesian plane where have x-axis and y-axis. Now every root that you see here, every point that you see here is what we call the root. First, this is the first point, what we call the root. If the root going down to the under the x-axis is what we call the minimum root point. Minimum root point, where f of x is equal to 0 and f double prime x is less than 0. And if the root is going up over the x-axis, it's what we call the maximum root point. Maximum root point. Where f prime x is equal to 0 and f double prime x is greater than 0. And that is the plot of the root and optimization.
Hey guys, good day, and today to continue our discussion, our topic today, and we're gonna discuss about the graphical method. Graphical method, a simple method of obtaining an estimate of the root of the equation f of x. The equation f of x is equal to 0. To make a plot to solve the function of sense where across the x-axis, okay? In order to have our better understanding, we gonna have our example over here. We have x1 is equal to 4 1 sub 1, x square is equal to 3, and then x1 plus 2x square 2x1 2x2 is equal to 2. In order to find or to solve this example, we gonna make our y and x coordination or our Cartesian plane. We draw first our x and y axis, our x axis over here and our y axis over here, and then the point over here is our 0. The point over here is 0, and then 1 2 3 4 5 6 and so on and so forth. We have here 2 and we have here 4, and we have here 6, and together with here we have the same like this, 2, 4, and 6, and so on. Okay. In order to find this example, we're gonna plot first, or we can show this this example in here with here in our y and x coordination. Okay. Our 4 over here is this one going here, and our 3 over here is this one, because this is 2 and here is our 3. Okay, let me adjust this one. Let me put this one here. Okay, this 3 over here, there, over here, and the intersection is over here, and this one is our 4. This one is our 4, and this one is our 3. Okay, this one is our 3 over here. So, and then we gonna draw the line over there, and from here going there. Okay, because this is our intersection, because this is our point intersection of 4 and 3. So in order to find this example, this example is this is here, this one is over here. Okay, so x1 plus 2x sub 2 is equals to 2. This one is over here, inside here, and this is our 4 over here and 3 over here. Okay, so I hope you got it, guys. Thank you. We proceed to our next topic. Thank you.
Yes, good morning, sir. This is the continuation, and let's talk about the bracketing method. Talking about the bracketing method. So first, bracketing method is two bracket across the y coordinates, x coordinates, and y coordinates. So first, we draw a Cartesian plane. We plot here, and the point here is the x lower, and another here is the x upper. X upper, X upper, and the X and the center is what we call the root of f. The root is equal to f of x. F of x is equal to 0, and then the x lower is connected to the upper right of the plot, and the x upper is connected to the lower plot, the lower point of the plot. So to solve the XR, this is the XR. The equation that we use to solve the XR, first the f of x upper is what we call the positive VE, because he is going up along the x-axis, so that he is positive, and the f of x this is the lower is the positive going up, and then the f of x upper is the negative VE, because he is going down along the axis. And then the equation that we use to
Fine, to solve.
solve this equation, xr is equal to x lower plus x upper over 2. This is the equation we can use to solve this problem. Thank you.
Okay guys, welcome back again. At this point of time, we're gonna discuss a open method. In order to understand open method, we gonna first make our Cartesian plane. We gonna make first our Cartesian plane. This is our y-axis. This is our x-axis over here. And we gonna make this is we have a slope over here. And this slope over here is what we call f of x. This slope over here is what we call f of x. Okay, in open method guys, we gonna guess that where we can put our point, everything here except in this x-axis over here. Okay, let's guess that we gonna first make here x1. Our x1 here is we gonna plot here up there to our slope, and then until they will intercept at this point. Okay, and this point over here, this is what we call f of x1. This point over here from here is what we call x of f of x1. Okay, to find this f of x1, we have y minus y1 is equal to m x minus x1. If we evaluate this equation, we gonna have a f of x minus f of x1 is equal to f prime x1 times x minus x1. Okay, this is instead of we using this y here, we gonna make this y like this. Okay, this y minus y1 over here up there is equal to this equation. Instead of we using this y, we gonna make this equation like this: fx1 minus fx1 fx minus f of x1 is equal to the m over here is the derivative of here of this one. This is m over here is equal, excuse me guys, is equal of f prime over here. This m over here is also equals to here, and still we gonna make this one like this. Okay, x1 x f of f prime times x1 times x minus x1. Okay, this equation guys is from this plot over here, and we gonna have our straight line from there to here. Okay, so this point over here is our x2. This point is our x2 over here. This point, this straight line from our slope to our x-axis, this is our x2. Okay, this is our x2, and that x2 we gonna make our line or graph up here, and this one over here is our f of x2. Okay, this one is f of x2, and then to find this x of f2, we still have like this equation. Because why? Because this is the same as long as the point is the same plot in here, this is the point is here, still here in our x axis. Okay, so x2 is still like this, but instead of y sub 1, we gonna use y sub 2 like this. And for you to understand, then I will write it again. Okay, so y minus y2 is equal to m x minus x and 2. Okay guys, if you observe this, equation over here is the same this equation, but only change is this x over here, because we gonna compute this point over here x2 and this point over here f of 2x. Okay, so let's change this x of 2 because our point to find is this point over here. So the same like this, if we evaluate this equation or this equation, so we gonna have like f of x, f of x minus f of x2 is equal to f prime f x times x3 minus x2. Okay, this equation over here is the same like this, but only change is what the point. For example, this point over here is point 1 x1, and then we gonna use x1. So if we solve this problem, or if we find this x2, we gonna use x2 over here and here. Okay guys, so you hope you got it. And then
Let's continue. And let us tackle about the simple fixed point iteration. If we given f of x is equal to 0, write x in terms of x is equal to something, and then label left side as xn plus 1, and right side with x sub n. So we're going to pick x sub 1 and plug into equation. Repeat, and then repeat until converges. So let's go into erase this one. If we give an example, find where x squared minus x squared minus x minus 1 is equal to 0. Now, the given equation here is x sub 2 minus x sub 2 is equal to x plus 1, and x is equal to 1 plus 1 over x. X sub n plus 1 is equal to 1 plus 1 over x sub n. Now, if we're going to pick x sub 1 is equal to 2, pick x sub 1 is equal to 2. Now, to get x sub 2, we're going to plug the x sub 1. X squared, x sub 2 is equal to 1 plus 1 over, we plug the 2, is equal to 1.5. And then, to get x sub 3, we're going to plug the 1.5 to get the x sub 3. So x sub 3 is equal to 1 plus 1 over 1.5 1.5 is equal to 1.6666. And then to getting x sub 4, we're going to plug the 1.6666. So x sub 4 is equal to 1 plus 1 plus 1 over 1.6666 is equal to 1.6. And then to get again, to get x sub 5, we're going to plug the 1.6 to get x sub 5. X sub 5 is equal to 1 plus 1 over 1.6 is equal to 1.625. So let's erase this first. Let's continue. So to get again the x sub 6, let us plug this to get the x sub 6. X sub 6 is equal to 1 plus 1 over 1.6.625 is equal to 1.6 1.25 3 8 4 6 2. So it is converging to 1.618. Is converging. And another solution, if given x minus 2, x squared minus x minus 1 is equal to 0. Another solution, x sub 2 minus x is equals to 1. X quantity of x minus 1 is equal to 1. And then x is equal to 1 over x minus 1. And then x sub n plus 1 is equals to 1 over x sub n minus 1. So, pick x sub 1. Pick x sub 1 is equal to 1.6. Then, let's use this x sub 1 to find x sub 2. So, x sub 2 is equals to 1. This, and then we plug this 1.6. 1.6 minus 1 is equal to 1.6666. And then to get x sub 3, let us plug this. X sub 3 is equal to 1 over 1.6666 minus 1 is equal to 1.5. And then to get x sub 4, x sub 4 is equals to 1, and plug this 1.5 minus 1 is equal to 2. So it is not converging. It is not converging. Not converging. Okay, that's all. And thank you. Now, f sub prime x sub 1 approximate equal f x sub I minus 1 minus f of x I f of xi over x sub I minus 1 minus x sub I. Okay, now let's go into substitute. Substitute x sub 1 plus 1 is equal to x sub I. Now, negative f of xi times xi minus 1 minus x sub I over f of x sub I minus 1 minus f x of I. Okay, let's erase this first. The formula of second method. This is the formula of second method. F sub prime x sub I. X prime of x sub I f of x f prime of x sub I
Approximate equal
to f x sub I plus 8 x sub I minus f x sub I over 8 x sub I. Now, where 8 is equal to small part perturbation fraction. Substitute into or 8 is equal a small perturbation fraction. Now substitute into here x sub I plus 1 is equal to x sub 1 minus 8 x sub I f x sub I over f of x sub I plus 8x sub 1 minus f x of I. So that is the equation of second method. Thank you.
Hi, welcome guys. Welcome back again to this discussion. At this point of time, we're going to discuss a polynomials. Polynomials are the special type of non-algebraic equation of the general form like this. Okay?
Yeah.
This is the general form of polynomials. F of n of x is equal to a sub 1 x raised to the n plus a square or a sub 2 x raised to double prime raised to 11 minus 1 plus so on and so forth a n minus 1x square plus a n x plus a n plus 1. Okay, we're gonna put the plus 1 here. Okay, plus 1. This form here, guys, this form over here is the general form of polynomial function. This form over here is the form of polynomial function. Okay, so where this n over here, as you see, our power here is n, a1 x raised to the power of n. The n over here is n is the order of the polynomials. Okay, this n or this n over here, wait a second, this n over here or power n over here is what we call the order of polynomial. As you can see here, we have a x to the power of n and a sub n. This n over here is order of polynomials. This one is order of polynomials. And then, as you can see, we have one here, a. This a over here is what we call the a's are constant coefficient. Coefficient. Meaning to say, this a over here is constant. Whatever happened to this function, this a over here is steady, or what we call constant. This is even if we substitute to other form, but the value of a is still constant. So as we go on, we gonna delete this one, or we gonna erase this one, for we have a space for our example. Okay, wait a second guys, I will erase this one and then we just continue to our discussion. So in addition we have a example. Here is our example: 3y raised to the power of 5 plus y raised to the power of 4 plus 2y raised to the power of 3 minus 2y plus 5. This is our first equation. This is our first example. This is our first equation rather. Okay, sorry. This is our first equation. And second one is plus, this is the continuation, plus 2y raised to the power of 5, 2y raised to the power of 5 plus 3y raised to the power of 3 plus 3y plus 2. As you can see here, almost our equation over here and this one is almost the same. Almost the same, right? Okay. As you can see here, 2x raised to the power of 5, the same function, the same power, and here we have 3y. What we going to do is we gonna arrange first to the same like this. In order to have to add this equation, in order to have this equation, we gonna first arrange or rearrange to the order of polynomials. Okay, so let me first delete this one and we rewrite this one as you to have a better understanding, because our space is very tiny, so we don't have a whiteboard. Okay, as we continue, our example is 3y raised to the power of 5 plus 4y raised to the power of y raised to the power of 4 plus 2y raised to the power of 3 minus 2y raised what we have no power here, plus 5 all over, or plus, because we going to undergo the polynomial in addition. Okay, this is in addition. This is an example of addition in polynomials. Plus 2y raised to the power of 5 plus 3y raised to the power of 3 plus 7y plus 2 over. As you observe guys, because this equation over here is we cannot see the same function of this y raised to the power of 4. That's why the space over here is empty. It is because the order of polynomials in additional is dapat daw ay magkapareho. Yung dito na function, dapat ang sa ilalim nito ay kapareho din na function. So in that ways, we can empty this one. Because in addition, this is the rule of addition, that if no value that the same like this in other equation, we cannot add this one. So what we going to do is just copy this function over here. So we gonna add this one because we undergo to the polynomials in addition. So we gonna have 5 2 plus 3 is 5y, the same power, because in addition, if the power is the same, we just copy this one. Okay, so 5y raised to the power of 5 plus, because we don't have a value over here, we just copy this one, y raised to the power of 4 plus 2 plus 3 is equals to 5y, copy the y over here, y raised to the power of 3, because 3 over here and 3 over here is the same, we just copy that one, 5 5 3 plus we gonna add this one. 7 plus 2 is we have, okay, so the sign over here is negative and the sign over here is positive. What we going to do is minus this one. Okay, so 7 minus 2 is equal to 5. Copy this one is y, plus, because we have the same sign here, we have a positive and positive over here, we just add this one is equal to 7. So guys, this is what the result of this equation over here in terms of addition. Again, if the value, if this equation of the lower equation is no value like this, we just add this, we just copy this one. And if the power is the same, we just copy that power. Okay, so thank you guys. I hope that you have a even in the small understanding. I'm so happy about that. Thank you. Welcome back, guys. At this point of time, we're going to discuss the pipe friction. This is the last topic of last chapter in our report. Pipe friction. Pipe friction is in a fluid flow, friction loss. Meaning to say, pipe friction, this is the friction loss. Pipe friction is the friction loss. Wait. Friction loss. Ibig sabihin, pipe friction is the friction loss. So, or head that occurred in the pipe duct flow due to the effect of fluid viscosity near the surface of the pipe car duct. Equation of pipe friction is 0 is equal to 1 over square root of F, or force, square root of F plus 2.0 logarithm of E over 3.70 plus 2.51 over RE square root of F. So with this equation, we gonna solve the pipe friction. This equation is when we use at all of this topic. Okay, so where E over here is the rightness of M. The rightness of M, roughness pala to, roughness, the roughness. Okay, so the V is diameter, and the last one is RE. This RE over here is the Reynolds number. The Reynolds number. This RE, or this RE over here, from our equation E or the roughness over 3.70 plus 2.55 over RE. This RE over here is the Reynolds number. This RE over here is a Reynolds number. So as we go on, we have a one equation for this topic. Okay, we gonna delete or erase this one, for we gonna continue because our space is maliit. Kunti lang yung ating space, wala tayong pambili ng whiteboard or yung malaking ganito. Ito lang yung makaya. So hope you understand me, guys, together with my my group, Mr. Deliverio Marvin. So we continue. while ago, the RE over here, wait, I'm going to rewrite our equation. O is equal to 1 over square root of f plus 2.0 logarithm of e over 3.70 plus 2.51 over re square root of f. So this is our first this is the equation of to find or to solve the pipe friction. So in order to solve this value, we have the equation of this RE over here, because we can calculate the pipe friction, we can calculate this formula, we cannot calculate the equation of this pipe friction if we don't have or we can first solve this RE over here. So the formula or the equation of this RE is equal to P, V, and D. This P is the density, okay? This P over here is density, and this is the dynamics viscosity pa to? Dynamics viscosity to. Ay, meron pala nito. Where P is the fluid density. The fluid density. The fluid density. Wait. The fluid density. And V is the viscosity. Viscosity. And U, or seems like U, is dynamic viscosity. Okay. In order to solve this RE, we gonna first find this P over here. This P, or the density, the formula of density is P is equals to mass over the gravity. In order to solve this equation of RE, we gonna first find our density over here. We gonna first find our density, and then we gonna get this equation of RE. Okay, so that is all. Thank you, and God bless.